Let me see. All right. So we're going to go ahead and get started. We'll fix that later. All right, gentlemen, welcome. Hopefully you enjoyed your weekend. Hopefully you enjoyed your homecoming. I heard that we did not win. I don't remember the last time we won a homecoming game. It's rare that we win the homecoming games, and it's kind of bizarre, like being an alum of Morehouse. It's just it's okay. It's all good. It is what it is. But hopefully you were able to enjoy yourself. We are at the top of week 11, right? Week 11. So what that means is that next week we're going to be working on exam 3. Okay, that exam should become available this upcoming Sunday at 11:11 a.m. It'll be due the following Sunday at 11:59 p.m. And so all the next week, I'm just going to be on the Zoom call just to answer questions. You can ask me questions about anything that's on Zoom, even your current exam that you're working on. If you're working on it and you just can't figure it out, you can ask me and we can work on it together. All right, it's totally okay. You get unlimited attempts. The system is set to take your highest score, and it's basically gonna be a new exam each time you take it. Same content, but a lot of stuff gets shifted around or whatever. If there are interactive figures, I'll probably just give you credit for those questions. So I'll try to keep those to a minimum. And as always, we have our usual setup where this is remote asynchronous. You know the spiel there. If you have questions, comments, or concerns, my recommendation is to unmute yourself to get my attention, or you can type in the chat. I do check the chat periodically. And so exam 3 is going to cover chapter 2, and we've been kind of working on like polynomials, all right? So today we're going to be working on section 2.3, dividing polynomials into rational zero tests. Let me check Zoom one more time. Okay. All right. And a few objectives here. We like to learn the division algorithm. We'd like to use the remainder and factor theorems. And we like to use the rational zero tests. Okay. So a polynomial factor, a polynomial d of x is a factor of a polynomial f of x if there's a polynomial q such that f is d times q, right? So f we call the dividend, d we call the divisor, and q we call the quotient. Okay. So then if you have the dividend divided by the divisor, the output is going to be your quotient plus the remainder over the divisor. Now we can use algebra. We can use algebra to solve for your dividend here. Long story short, you'll get your dividend equals the divisor times the quotient plus remainder, right? So that's like a synopsis of the division algorithm. A more simple way to visualize it, it's going to parallel regular long division. All right. So the same way you just do long division, the division algorithm here for polynomials is going to be similar. Now, my device has kind of been on the fritz every time I try to add a page throughout the day. This is the first time it's worked all day. I need 1 there and I need 2 here. One more. And then template, and I need this to be like this. Apply. Cool, that looks good. Okay. This is where we left off. Cool. All right, that's the first time this worked all day without any trouble. And we are definitely missing some people. Like there are some people I know I have not seen in a minute. So now I need to go track them down. They might be booted from the class. It's gonna be money. I don't even know if they intend to still be here or not, but there's definitely some students I need to track down and report. Some students intend to be withdrawn because they just are missing, but that's money. I mean, you gotta, obviously they have a plan or something. You gotta have a plan with all this stuff. And with anything that happens, whatever grade you get, know that there's always another way, all right? There's always a way to get things done. If you're talking to one person and they're not saying what you want to hear, you just got to talk to somebody else. You're talking to the wrong person. Okay, so as a demo, right? So let me see the time right now. I have it's 4:00. It's just about to be 4:06, right? Let's add a 2 onto this, and let's divide this by 6. Now, say we were doing long division like this, all right? So then, if we were doing long division, we would ask ourselves, oh, how many 6s are 40? Is what 6, right? So then 6 times 6 is 36. So on the diagonal in this direction, we multiplied, right? Vertically, we add, or actually we're subtracting, right? So then that difference is 4, and then the 6 comes down, right? 42, 48. So then 7 is 42. Again, we subtract. Right, so the steps that we would do here are the same steps we're going to do for our division algorithm. It's similar. What is that, 4? 42, this is 42, is 7. The remainder ends up being 0 here. Okay, so the same steps we took here to do this long division, when we do our polynomial long division, it's done in a similar fashion. Okay, so an example on using long division and synthetic division: use long division and synthetic division to find the quotient and remainder when this dividend is divided by this divisor. And we start by performing long division. So we're going to do a demo on polynomial long division and a demo on synthetic division. Let me start by getting a copy of this question. Kind of want it like this. I think that's good like that. Take that and drop it here. Let me see, does that change it? Format, disable wrap text, does that do it? Like they changed the settings. It used to be where if I resized it, it would collapse it to the right size. But that's not doing it. I don't know what setting I need to change to fix that. But we can work with this. Okay. Oh. All right, that's fine. Oh, that's too big. Let's see what's going on. Okay, that's fine. Okay. And I want to do one other thing. Yeah, kind of like that. Okay. So for polynomial long division, first thing we put this divisor on the outside. So this x plus 2 is going to go on the outside. And then we want to rewrite our dividend, but we need to make sure that every power is accounted for. So if we're missing a power, we're going to need a placeholder. So we got this 2x to the 4 plus x cubed minus 16x squared. Notice that the power of 1 is missing. So we're going to say plus 0x. We needed a placeholder. And then plus 18. We started with the degree 4 polynomial, so that means we should have 5 terms. 1, 2, 3, 4, 5. Okay. So then once that's done properly, let me move this down some. Okay. And let me copy this, paste it here. It's good about there. Okay. Yeah, that's what I want. Okay. Okay. So when we go to do polynomial long division, we're going to say this first term divided by this first term. And I think the output is 2x to the power of 3. And I'm lining up my like terms. On the diagonal, we multiply. So in this direction, we're going to multiply. Okay. 2x to the 3 times x is 2x to the 4. 2x cubed times 2 is going to be 4x cubed. Okay. And then I think on this line, we subtract, right? So we need to distribute a negative. So if we combine like terms, a number plus its opposite as 0. 1 minus 4 is negative 3x cubed, and then the 16 comes down. So you'll see a lot of similar edits to like when we did it with the numbers. This is done in a similar fashion. Negative 16x squared. So now we say the first term divided by the first term gives us a negative 3x squared. 3x squared like this. Now repeat. This times this is going to be what? 3x cubed. Negative 3x cubed minus 6x squared. We need to distribute a negative, so this is going to become positive. That becomes positive as well. Combine like terms, a number plus its opposite as 0. Negative 16 plus 6 is going to be negative 10x squared. Okay. And then this 0 comes down. Okay. Then we say negative 10x squared divided by x gives us negative 10x. On the diagonal, we multiply, so we're going to get negative 10x squared minus 20x, okay? We need to distribute a negative, so this becomes positive, this becomes positive. A number plus its opposite as 0. 0 plus 20 is 20, and then this 18 comes down. Okay. 20x divided by x is 20. Diagonal we multiply, so we're going to get 20x plus 40. Distribute your negative. A number plus its opposite as 0. And it looks like our remainder is going to be negative 22. And this was our quotient. This was the result that we got. Okay. Let me check Zoom really quickly. Okay, we got some people. All right, so we just went through a demo on polynomial long division. Now so we got what you see at the top with a remainder of negative 22. Now let's see that something similar, but now we're going to see what's a technique called synthetic division, right? So now if we're going to do synthetic division, let me see if I go like this. Does that do it? That does do it. So when we go to do synthetic division, the first thing is we need to identify what goes in the chair. So the 0 of your divisor goes in the chair. The 0 in this case is going to be negative 2. So that means negative 2 is going to go in our chair. Okay. So just like before, but now we want to take the coefficients of each term using placeholders as needed. There's a placeholder we're going to need here because the power of 1 is missing, right? So we want to take the coefficients. So it's going to be 2, 1, negative 16, 0, and then 18, all right? We started with a degree 4 polynomial, so that means we should have five coefficients. 1, 2, 3, 4, 5. Okay. So that's the structure for synthetic division. So then the first things are whenever we go vertically, whenever we move vertically, we're adding. On a diagonal, we're multiplying, right? So the first thing is that this 2 just comes down. It's like 2 plus 0 is 2. Now on a diagonal, we multiply, right? Negative 2 times 2 is negative 4. The answer goes here. Vertically, we add. Diagonal, we multiply. Then if we add again, we're going to get what? Negative 10. If we multiply, we get a positive 20. Vertically, we add. We multiply. And then if we add one more time, we get negative 22. And that's our remainder. Okay. So then, if we started with the degree 4 polynomial, at this point, we now have a degree 3 polynomial. Right? This part here is what we call the depressed equation. Right? So when you say this polynomial divided by this divisor, we got this result and this remainder. Or in other words, this quotient and this remainder. Okay. Okay. So, we saw a demo on using polynomial long division and synthetic division. Now, in my opinion, synthetic division is much easier. It's just that we don't always have the luxury of using synthetic division. We can only use synthetic division when we're dividing a polynomial by a linear binomial, so something that takes on this form. If that was like a power of 3 or anything other than a linear binomial, then we can't do synthetic division, and we would have to go to polynomial long division. Okay. And here's a typed version of what we just did. Okay. Ouch. Getting all these aches and pains. And I know it's coming from me being too inactive, like I need to run around some. I just haven't done any of the other things I told myself I was going to do. So I feel sick as a result. I need to just get up and move. It's like whenever I get up and move, I always feel better. Anyway, let's keep going. So we have this thing called the remainder theorem. If a polynomial f of x is divided by a linear binomial, then the remainder r is given by this. The remainder is going to be f of a, right? So if you want the remainder from this division, then you can just say evaluate f of a and vice versa. Okay. So here we're asked to find a remainder when this polynomial is divided by x minus 1. Okay. Okay. So the remainder theorem just said the remainder is going to be equal to f of a. Okay. So in this case, that's going to be our a in this case is 1. So if we evaluate f of 1, that should get us our remainder. That's going to be 2 times 1 to the 5th minus 4 times 1 cubed plus 5 times 1 squared minus 7 times 1 plus 2. That's going to be, that's going to be 2 minus 4 plus 5 minus 7 plus 2. All right. If we combine like terms, 2 plus 2 is 4, minus 4 adds 0. 5 minus 7 is negative 2. So the remainder here is negative 2. And we can confirm that this is the remainder if we just go ahead and do our polynomial long division. Okay. Let me see. So if we're dividing by x minus 1, so the number that goes in the chair is our 0. Our 0, if we're dividing by x minus 1, is going to be 1. Now we take our coefficients using placeholders as needed. Notice we got 5. We're missing the power of 4. That's the one that we're missing. So 2. Then we need a placeholder for the power of 4. Negative 4, 5, negative 7, and 2. Okay. So then the first coefficient just comes down. On a diagonal, we multiply. Vertically, we add. Then we multiply. We add. We multiply. We add. We multiply. We add. We multiply. And the remainder is negative 2. All right, we got the same thing. So we confirm that we just basically confirm the remainder theorem that it works. Let me check on you guys in Zoom. Okay. And here's a typed version of what we just did. Okay. So let your dividend be this guy. We're asked to evaluate f of 3, right? So obviously we could just plug in -3 and we get an output, but they basically want us to apply the remainder theorem. So instead of just plugging in -3 and getting an answer, we can do synthetic division, and the remainder is going to be the same as if we were to plug it in and just get an answer, right? So we can do synthetic division and look at the remainder. So in the chair goes -3. Okay. We take our coefficients. First, we need to see if we need any placeholders. We got 4, 3, 2, 1, 0. So we're good to go. We don't need any placeholders. So then if we take our coefficients, we have 1, 3, -5, 8, and 75. Okay. Notice we started with the degree 4. We should have 5 coefficients. 1, 2, 3, 4, 5. Okay, so we're in the clear there. The first coefficient just comes down. On the diagonal, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, and we add. And this is our remainder. So then what the remainder theorem is telling us is that f of -3 equals 6. Now, if you try to plug in -3 into the original, you're going to get some astronomical numbers, and then you're going to be giving yourself a headache, right? But we can just do synthetic division here and get the same result. Now, we can confirm this if we just evaluate this function when x is 3. So let's do that quickly. This guy right here. Okay. I'm going to go to my y equals. Do I have it already? No. Let's type it in really quickly. We got x to the power 4. So x hat 4 plus 3x hat cubed minus 5x squared plus 8x plus 75. Okay. So there's our original function. We want to evaluate this function when x is 3. So I'm going to just call it here. And x is 3, right? Actually, when x is -3. We should get 6. Okay. So we saw that, we did it both ways. We evaluated this function when x was -3. We also did synthetic division. When we did synthetic division, the remainder was 6. In either case, evaluating or the remainder theorem, we got the same result. Okay. Here's a type version. So you can see, oh, this is always my favorite part of the day. Like, I always get like kind of antsy because you guys are my last class. So then I'm about to say like deuces, shut everything down and like hop in the bed and like zen out. I've been watching, I don't know, I've been making my way through like Netflix, man. Netflix, like shameless like marketing for Netflix. This is an epiphany I had with the students earlier. It was like, we so effortlessly do free promotions for like these other companies, making them more money. I'm like, but what does it take for us to promote our own stuff and make money for us? I think the first line is we need to be producers. We got to be making something. If you don't have a product, if you're not selling anything, if you're not producing anything, or even offering a service or something, then how do you expect money to come in, right? So you got to offer something. I do feel some way doing free promotions or free marketing for these companies. Unless they were paying me for it, then that would be different. But I've been watching like this movie called One of them was this movie called, I mean, it's so much. It was The School for Good and Evil. It was basically in the top 10 trending now, whatever. I was like, okay, it was better than I thought it was going to be. I enjoyed it. It was entertaining and a little bit thought provoking. So it was okay. I enjoyed that one. And then like now I'm watching this series called Who's the Mole? So it's like Imposter Among Us kind of thing. I was like, and they're sabotaging the efforts. I think I know who it is, but you know, I'm trying to get to the end of it. But yeah, it's fun. You know, just trying to figure out who it is. But anyway, that's neither here nor there. But I kind of did want to try like a day where we do play Imposter Among Us, some way where we can all like just play together, and especially if I can find a way to tie it into what we've been doing, just to have some fun and you know build like some camaraderie or whatever. I just think it will be fun. But yeah, so I'm kind of open. But let's keep going. So we saw an application of the remainder theorem in both directions, using the remainder, you know, using the remainder to evaluate a function and evaluating a function to find a remainder, right? We just went in both directions. So then here we have the factor theorem. So a polynomial f of x has x minus a as a factor if and only if f of a is 0. In other words, if the remainder is 0. All right. So we say that this is a factor of the original polynomial if the remainder is 0. Okay. So given that 2 is a 0 of this function, solve this polynomial equation. I don't think I need another piece. So let me think. Okay. So if 2 is a 0, let's confirm that 2 is indeed a 0. We can do synthetic division. And when we do synthetic division, our remainder should be 0, right? So if 2 is a 0, that means 2 goes in the chair. We need to see, do we need any placeholders? So we have power 3, 2, 1, and 0. So we don't need any placeholders. So if we take our coefficients, we have 3, 2, negative 19, and 6, okay? So if we do synthetic division, the 3 comes down. That's a 6. So on the diagonal, we multiply. Vertically, we add. We get 8. We multiply. 8 times 2 is what? 16. Vertically, we add. We get negative 3, negative 6. And we indeed got our remainder of 0, right? So that confirms that 2 is indeed a 0. So now we need to factor this out. So we started with a degree 3 polynomial. So at this point, we're now at a degree 2. So this is really 3x squared plus 8x minus 3. This is called the depressed equation. Okay, so if we're going to factor that guy, we're looking for two numbers. Let's go ahead here. Two numbers that multiply to give us, I'm using my A times my C. So two numbers that multiply to give us negative 9 and add to give us 8 are going to be negative 1 and 9. Okay, so I'm going to use the box method to factor this guy. So let's work over here. Box method is going to be something like this. So in the upper left-hand corner, we do that leading term, which is 3x squared. The bottom right-hand corner, we do the constant term. And then on the other diagonal, we're going to rewrite this orange 8 using the two numbers we just found. So I think we're going to rewrite 8x as 9x and negative x, okay? So then if we look at these two numbers on top, what do they have in common? We can factor out 3x from both of those guys, okay? And if we look at these two numbers on bottom, what do they have in common? We can factor out a negative 1, okay? If we look at these two numbers on the left, we can factor out, they both have x. And if we look at these two numbers on the right, we can factor out 3. Okay. So the claim, so let's write out what we have so far. We've confirmed that 2 is indeed a 0. So if 2 is a 0, then the factor is going to take on the form x minus 2. Now the factor that the depressed equation that we found, our claim is that it factors into 3x minus 1 times x plus 3. And we're basically solving this equal to 0. Okay. So if this is the completely factored form, we can use the zero factor property. When two or more things multiply to give us 0, we basically set each thing to 0 and solve. If we do this, we get the following zeros. 2 was the one that was given. If we said 3x minus 1 equal to 0 and solve, we get a positive 1/3 and then negative 3. Okay. These are the zeros that I got. Let's kind of go here. Okay. Now, if this were a testing environment, I would encourage you to plug these into the original to check to make sure they work. I guess we can just go ahead and do that here. Let's clear this out. Let's go to y equals. So let's put in the original. Let's clear. Let's see. Clear was like this one, or was it C? Nope. Did I hit B? Oh, okay. Clear. Oh, I got it. Is that one? Oh, I see. I see. I'm starting to see this stuff now. If I do N, it should be long. Oh, okay. I get how this thing. I get how it's organized now. So on this emulator, the green alpha corresponds to the keyboard, right? So for instance, if I want to hit times, it should be R. Yo, man, I was today years old when I learned how the shortcuts for this for this keyboard. Like, because I kept pressing buttons and I knew it was some kind of system, but I didn't know what the system was until literally right now. I got most of it. Now mode, I'd have to find that one. It's not that. It's not that. Let me see. That's okay. Oh. All right. But, you know, we got the rest of that stuff. Okay. So let me clear. See if I can find mode. There's a period. That one is normal. Nothing. Parentheses L. Okay, I see it. So they got two different ways to do parentheses. Negative 0. Okay, I'll find it. It's not a big deal. I'm not gonna do it right now. Okay. Anyway. All right. So if I'm going to do 3x hat cubed plus is quotes. No, it's not working. I found that button. But plus 2x squared is 2xi, okay? Minus 19x plus 6. Okay. Let's just quit. Bet just somewhere near there. Or maybe a shift or something. So I want to call on that function. Oh, we want to verify our zeros, right? So when x is 2, we should get 0. When x is, let's go ahead and do -3, we should get 0. And when x is 1/3, come on, 1/3. Oh, I did negative. It should be a positive 1/3. Okay, we get our 0. All right. So we confirmed that those three results work. In the original, they were 0, so we're going to go there. Okay. So here's a type version of what we just did. We're given that 2 was a 0, so we confirmed that 2 was indeed a 0. When we do synthetic division, we got a remainder of 0. So that's the confirmation, is that we got a 0 remainder. So then we use factoring. So after we confirmed that 2 was a 0, this 3x squared plus 8x minus 3, that came from the depressed equation after synthetic division. Then it's factoring from that point, and then, you know, we got our results. Let me check on you guys in Zoom real quickly. All right. I'm going to leave this one as an exercise. If you want to see it, either requested, but I have it in my pre-recorded lecture just for that one is just an application of the quadratic formula. You can see it, but I want to talk about this on the rational zero test. This is like the last part. Okay. So with the rational zero test, if f of x is a polynomial function with integer coefficients and the leading coefficient is not zero and the constant term is not zero, and p over q is a rational number in lowest terms that is a zero of f, then p is going to come from a factor of your constant term. Q is going to come from a factor of your leading coefficient, right? So the rational zero test is basically doing this p over q. When we do the p over q, we're going to get this list of possible zeros. So if our polynomial has a rational zero, it's going to be somewhere in that list. So we have to go through that list that we generate and find the zeros to solve the equation, right? So here we're asked to find all rational zeros. So it's an application of the rational zero test. So then we want to do p over q. So we're going to say p over q, okay? So the p comes from the factors of our constant term. Those factors are basically going to be plus or minus 1 and plus or minus 3, right? Then we're going to say divided by the factors of our leading coefficient, which are plus or minus 1 and plus or minus 2. Okay, so we want to do all combinations with the pink with everything that's in blue. Okay, so possible rational zeros, plus or minus 1, plus or minus 3. So that's 1 over 1, 3 over 1. And then plus or minus a half and plus or minus 3 halves. So what we're saying is that if our polynomial function has a rational zero, it's somewhere in this list. So we have to go through this list and test these out. I'm going to start off with just 1, right? So my claim is that 1 is a 0. So if I do synthetic division with 1 in the chair, the remainder should be 0. If we're going to do synthetic division, we got 3, 2, 1, 0. Every power is accounted for, so we don't need any placeholders. We take our coefficients, 2, 5, -4, and -3. Okay. The 2 comes down. Diagonal, we multiply, we add, we multiply, we add, we multiply. Wait a minute. It's a positive 3, right? We multiply, we get this, we add. Okay. So we almost missed it. If we had made a mistake and we didn't catch it, we would have missed out on one of our zeros. Okay. But we officially found 1 0. Again, we started with a degree 3. So that means at this point, we're now at a degree 2 polynomial. And we want to factor that guy. Okay. So I'm a fan of the AC method of factoring. So we're looking for 2 numbers that multiply to give us 6 and add to give us 7. That's going to be 1 and 6. Okay. So then I'm just going to use my box method from here. In the upper left-hand corner, I'm going to do 2x squared. Bottom right-hand corner is 3. And then on the other diagonal, we're going to rewrite this 7 here. We're going to rewrite that 7 using the 2 numbers that we just found. So we got a 6x plus 1x. Okay. So then when we go to use this box technique, what do these two have in common? What can we factor out of these two guys? They both have 2x. What do these two guys have in common? Nothing, so they have 1 in common. What do these two guys have in common is what? X. And what do these two guys have in common is 3. Okay. So let's kind of combine what we have. So we confirmed that 1 is a 0. So that means if 1 is a 0, then the factor is going to take on the form x minus 1. And then our claim for the factorization of this depressed equation is going to be 2x plus 1 times x plus 3, right? And this is basically the the fully factored form of the original, right? The original and completely factored. So then our claim, so then if we set this equal to 0 and solve, then we can use a zero factor property, set each factor to 0 and solve, and we'll get that x equals, we get a 1. Looks like that's a -1/2 and -3. And we just need to confirm that these work in the original before moving forward. Okay. Okay, we are in the home stretch, gentlemen. Let me just check this as quickly as I can. And what I'm going to do this time, I'm going to put this right here, like that. So we can see what we need to see. I'm going to go, let's clear all this out. I'm going to go to my y equals and clear that out. Now we got a 2x hat 3 plus is this. That didn't work. This one, okay. 2x cubed plus 5x squared. So let's see, 5x squared minus, which is w, okay. 4x, so 4x. Sorry, I'm still just minus, which is this one. That's not minus, that's negative. Minus is w, minus 3, okay. Let's go back to the home screen. And I just want to call in the function. So when we plug in 1, the output should be 0. When we plug in a -1/2, output should be 0. And when we plug in -3, the output should be 0. Okay. So we confirm that those 3 zeros work in the original. And that's about the best we can do. Okay. Here's a type version of what we just experienced. Let's see. So P comes from the factors of the constant term. Q comes from factors of the leading coefficient. The factors of -3 are these guys. The factors of 2 are these guys. So the possible rational zeros are here, which is what we got. And then you have to go through that list and find the actual rational zeros. They tested 1 first. They got a remainder of 0, which is what we got. So that tells us that x minus 1 is a factor. And then once you get it down to a quadratic, you can use like quadratic formula or any of your favorite factoring techniques, right? And I think they got the same thing that we got. All right, and I think that's it. Did you guys have any questions? I feel like there should be questions, but most of the times this topic is like intimidating to the students, you know. Let me go ahead and send you a copy of this. I think that looks good. Let me send it a box. So when this bar finishes loading, you'll get a copy of everything that you saw me writing. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. Okay, take care. Peace. That's fine. All right.